Welcome to my channel DF Scientific Look. Introduction to Sir Isaac Newton. Sir Isaac Newton, one of the most influential and revered scientists in history, was born on January 4, 1643, in Woolsthorpe, Lincolnshire, England. He came from a humble background and faced significant hardships early in life, including the death of his father before he was born. Despite these challenges, Newton demonstrated exceptional academic prowess during his early education at the King's School in Grantham. In 1661, Newton enrolled at Trinity College, Cambridge, where his brilliance in mathematics and natural philosophy soon became evident. He delved into the works of prominent scientists and philosophers of the time, such as Galileo, Descartes, and Kepler, which influenced his thinking and future discoveries. Newton's laws of motion. During the 1660s and 1670s, Newton developed his groundbreaking theories on motion and forces. In 1687, he published his seminal work, Philosophiae Naturalis Principia Mathematica, Mathematical Principles of Natural Philosophy, commonly known as the Principia. This monumental work laid out his three laws of motion. Newton's first law of motion, law of inertia. An object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity, unless acted upon by an external force. In other words, objects tend to maintain their state of motion unless a force changes that state. This concept is often summarized as, an object at rest stays at rest, and an object in motion stays in motion. Newton's second law of motion, law of acceleration. The second law describes the relationship between an object's mass, acceleration, and the force applied to it. It states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The mathematical equation representing this law is F equals sine ma, where F is the net force, m is the mass of the object, and a is its acceleration. Newton's third law of motion, law of action and reaction. The third law states that for every action, there is an equal and opposite reaction. When one object exerts a force on another object, the second object exerts an equal and opposite force back on the first object. This law highlights the symmetry in the interactions between objects and is often illustrated by examples such as the recoil of a gun when it's fired or the motion of a rocket in space. Universal gravitation and Principia Mathematica. In addition to his laws of motion, Newton made significant contributions to the understanding of gravity. While isolated in his hometown during the Great Plague of London in 1665 to 1666, he conducted profound research and discovered the law of universal gravitation. This law stated that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Newton's work on universal gravitation culminated in the publication of his Principia in 1687. This groundbreaking work presented a comprehensive mathematical explanation of motion and gravity, uniting terrestrial and celestial mechanics. The Principia marked a turning point in the history of science, providing a rigorous and mathematical approach to understanding the natural world. Newton's impact and legacy. Newton's laws of motion and law of universal gravitation revolutionized the scientific understanding of the physical world. His work laid the foundation for classical mechanics, and his ideas remain fundamental to physics to this day. Moreover, Newton's contributions extended beyond his laws and gravitational theory. He made significant advancements in optics, exploring the properties of light and proposing that white light is composed of a spectrum of colors. He also developed the first practical reflecting telescope, known as the Newtonian telescope, which significantly improved astronomical observations. Sir Isaac Newton's genius and relentless pursuit of knowledge earned him widespread recognition and honors during his lifetime. He was knighted by Queen Anne in 1705 and served as the president of the Royal Society from 1703 to 1727. His impact on science and his lasting legacy continue to be celebrated and appreciated worldwide. Newton's work serves as an inspiration to generations of scientists, and his ideas have shaped the scientific culture to this day. Conclusion. Sir Isaac Newton's life and work exemplify the power of human intellect and determination in unlocking the mysteries of the natural world. From humble beginnings, he rose to become one of the greatest scientific minds in history, leaving an indelible mark on the fields of physics, mathematics, and astronomy. His laws of motion and the law of universal gravitation not only transformed our understanding of the physical universe, but also paved the way for further scientific discoveries and advancements. Newton's Principia remains one of the most influential scientific books ever written and continues to be studied and admired by scholars and scientists worldwide. Beyond his scientific achievements, Newton's impact on the scientific community and his dedication to empirical inquiry set the standards for rigorous scientific investigation. His emphasis on using mathematics to describe natural phenomena laid the groundwork for the scientific method, shaping the way science is conducted to this day. Newton's legacy extends far beyond his era, as his ideas continue to be the bedrock of classical mechanics and have been incorporated into modern physics. Even in the face of newer scientific theories like relativity and quantum mechanics, Newtonian physics remains valid for most everyday situations and is a vital part of the education of every physicist and engineer. Throughout history, great minds have built upon the work of their predecessors, and Sir Isaac Newton's contributions provided an essential framework for subsequent generations of scientists. His impact on science and the world at large serves as a reminder that with curiosity, dedication, and perseverance, humanity can unlock the secrets of the universe and achieve great heights of knowledge and understanding. Sir Isaac Newton's legacy will undoubtedly continue to inspire and guide scientific inquiry for generations to come. Thanks for watching.